All right, welcome to CISS226, which is the Java programming class. We are, I trust everyone has read through the syllabus and instructions about how the class operates. If not, please do so. This class can be taken by you one of three ways. And it's not like you have to decide on one and stick to it. You can mix and match, but you can either attend the lectures in person, as some of you are. You can watch them live as they happen on WebCT, and I have a link to my WebCT room. Or you can watch the recordings later on in YouTube. So you can pick what works for you. If you are viewing online and maybe something particular gives you trouble, maybe you want to come into class that day, the next time or whatever. Or like if you have a doctor's appointment or whatever, and you can't be there for class or to watch it live, you can always watch the recording. So my aim is to make it flexible so that no matter what your circumstance, you have an opportunity to view the lecture. This is a blended class, which means that we meet only once per week. Last week being Martin Luther King Day on Monday, we did not meet at all. The semester actually didn't start until the following day. But so that we would not fall far behind, I put up a lecture for week one. And it went over the very basics of Java coding, and we'll go over those basics today. But make sure you understand the syllabus, make sure you understand the way the course is structured, and if you have any questions at all, let me know. I should have asked this at the beginning. Can you hear me online? People that are online, yes. Okay, great. Okay, let's talk a little bit about Java. Java, especially in its early days, big advantage was that it was platform independent. And it's platform independent because of the way that it works. You have your Java source code file. It's going to end in a Java. That's what you can read. It's human readable form. You can read it and understand it. That's where you type all your instructions in and so on. When you are done with that, you go through the process of compiling it. And that will make more or less for each Java class that you have, because you can have more than one in a program. It makes a compiled version of the program. All right, and is in byte code. Does anyone know what the name of the extension it gives when you compile? You know, it is slipping my tongue today, or slipping my head today. I know I'm going to kick myself when I see this. Of course, it gives you a class file. How did I forget that? I don't know. It's the beginning of the semester. I'm still a little rusty. And this is what's called byte code. Which is different than a computer's machine language. Computers, as you may know, and the bottom line, understand really one language, one machine language at its base. Now, we have many different programming languages and many different ways to write program, but they all, in one form or another, get translated into the machine language for it to work. And each type of machine is going to have a different machine language. Now, in the case of Java, you get this class file, which is platform independent. Which means that at least in theory, you could take a Java class file compiled on one kind of machine and run it on another, any machine that for which there is a Java virtual machine. This class file then, when you run the code, it's read by Java virtual machine. All right. And that actually does a translation to machine code and executes the program and so on. So if you want to run something on Java, on a certain platform, you just need to have a Java virtual machine for that. Now, people running Java programs only need Java virtual machine, but since we're going to be developing them, you need the JDK, Java Development Kit. And you can download that. If anyone has trouble downloading it, let me know. You should, by Wednesday of this week, be able to compile and run programs, and ideally have Lab 1. All right, that'd be a great thing for you to do today, is make sure that you have on whatever machine you're using, or you could use the lab machine, have your program complete and running. Okay, we are going to do the first number. We're going to do the first number of labs, really old school, right? Which means that we're not going to use a GUI, and we're not going to use an IDE. We don't create GUIs at first because they're a little tricky to create manually, all right? And we want to make sure you understand everything you create. We don't want you relying on dragging and dropping and things like that. We want to make sure you understand every bit of code on the nuts and bolts level. So GUIs are a little involved, so we're not going to use GUIs. And we're not going to use IDEs either, just to give you experience in working in this mode in the command line, because you can do a lot of things. So I have here sort of a souped up version of the example that we went over. I think it's the version we went over last time in the lecture. It's sort of a souped up version of the Hello World application, where it randomly chooses from a list of names and says hello to that name. So let me go and edit it, and you can use any plain text editor. I like Visual Studio Code. I'm going to open it up in Visual Studio Code. And here is the Java code. We'll take a look at it in a minute here. It's going to choose a random name from that list, and it's going to output hello, the random name. So we're going to assume everything is in the same folder. Again, in larger applications, that won't be the case, but we're starting small, so that will be the case for our examples. How do we compile something? We compile something by issuing the javac command. And then we can specify the name of the file that we want to compile. Usually when I'm compiling, I want to compile everything in the folder. So I just say compile.java. Let me actually back up and show you how to get into the command line if you're not sure. You just type in CMD from here on Windows. There's also a similar easy way to get it to it in the Mac. Then we're going to need to change the directory. If you put your folders on the desktop like me, you just need to CD to the desktop and then CD into whatever your folder is. LS will give you a listing of the files. LS-L gives you a long listing of the files. It's sometimes useful to see like if what version of the class file you have. So notice here, version of the class file is later than the version of the Java. So that's probably good, right? If the version of the Java was later than the version of the class file, that means I probably made a change and didn't compile it. So I'd be a little concerned. All right, now how do you run it? Just type in Java and the name of the class. You don't need the class extension. And as predicted, it says hello. And in this case, it randomly picked Mike as the name. All right. Now, make sure you understand that. Everyone should be able to do that. Even if you haven't written the program, everyone should be able to do that. I would hope like today in lab or on your own machine or whatever. All right. So let's look at the code. All right. These are Java comments. You can start a block of comments with a slash star and end with a star slash. I copied and pasted code from somewhere. And I left the comments as they were. All right. You're going to have public, class, and the name of your class. All right. Now, I'm going to be saying things that you have to do. I'm going to be saying things that you do by convention. Treat those as things you have to do too. All right. I shouldn't even have said that. It's like you got to do this, you know. Typically, class names are capital the first letter of each word. So in this case, it's hello world. It is capital H and capital W. Public simply means that this class can be seen by the outside world. For now, just make all your classes public, because for the first while, there'd be really no reason to make them anything but public. And this is indeed a class. All your code goes in a class. All right. All your code is going to go in a class. And you're going to have multiple classes for just about every program. This is about the only example I think you'll see in this class where there's only one class. The brackets, the curly brackets here, or braces, denote containment. In other words, everything in this hello world class is everything between here and here. Notice how neatly this is indented. I strongly encourage you to indent like this, because a very common error that you get is if you don't like line up things right, you'll have like one too many or one not enough of one of the braces. Well, here I can easily see this goes with that. This goes with that. And this is all part of this function. Another advantage of Visual Studio Code, if you notice, unless you would happen to be colorblind, you will notice that it's color coded too. I just saw we had something in chat. Let me make sure. Visual Studio Code does most of the heavy lifting, does a lot of the heavy lifting. That's true. It does a lot of stuff for you, which almost makes me not want to use it. Oh, that's okay. We're not interrupting. I encourage interaction. I was joking. I say almost makes me want to not use it. So you have to do it all on your own. Anyhow, within your application, you're going to have at least one class has a main function. The main function looks exactly like this. Java is case sensitive, so these things need to be written. The keywords have to be written in the case that they're designated here. Public simply means that you can run your application from the outside world, which again, would be very rare that you wouldn't want to do that. Static, we'll talk about what static means later on. It essentially means that that code exists. You can run that code without having an instance of the object. For those of you that have studied object-oriented programming. Void means this function does not return anything. If I had a function that returned whether a person was married or not, it would return a Boolean, right? Because true or false, either they're married or not. If I had a function that returned someone's age, it would return probably a integer, maybe a double if you wanted to do fractional years. All right. But in this case, this main function does not return anything. So you put void. Then we have the name of our function, which is main. Again, at least one at least one class in your application needs to have a main method because that's the code that gets the ball rolling. All right. That's when you go and run this, the main function is what gets executed. By convention, function names are lowercase, as are variables. So main is lowercase. Between the parentheses is the arguments to the function. This allows you actually to run and pass arguments into your code from the command line. We won't do it, but I could say, Java, hello world, and have an argument for the person's name instead of randomly choosing the name. And that would work just as well. All right, this is a function. Again, we have the curly braces to designate the beginning and end of the function. I declared an array. I'm going to generate a random number between 0 and 3.9 repeating. So 3.9999999. And I'm going to, let me rephrase that. I generate a random number. This part generates a number from 0 to 0.9 repeating. I multiply that by 4, so I get a number between 0 and 3.9 repeating. I then truncate the integer part, and I will return a value between 0 and 3. So this function will assign to this integer variable named random a value of 3. I sort of skipped this instruction. I'll go back and get it though. So random number 0 to 0.9 repeating, multiplied by 4, that will give us 0 to 3.9 repeating, truncate it to make it an integer. I then can create an array. And this is how we create an array. Like with the int, we put the type of data it is. This is string data. Int is an integer, this random one. And I put these square brackets indicating that this is an array. I can then assign values to the array this way by putting them in curly brackets. And you can refer to these elements by the index. So if I say name sub 0, I get Mike. Name sub 1 is Joe. Name sub 2 is Jerry. Name sub 3 is Joyce. So notice that that 4 corresponds to the number of values here. We'll talk about this 4 in a minute. All right. So we declare this array. We roll the random dice to get a number between 0 and 4, and then we output to the console the word hello plus the array element from the element from the array with the number of random. So if random is 0, it will output random is 3, it will output Joyce, and so on down the line. It's the hello world function, and that's our new improved hello world function. Now, where does the 0.9 come from? 0.9 comes from this function. This function will give us a number between 0 to 0.9. It's not the default value, it's the range of values it will return. So if I run it the first time, it might give me 0.678, blah, 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 blah. If I run it the second time, it might give me 0.129875. If I run it a third time, it might give me anything. It'll give me a variable or value between 0 and 0.999 repeating. That's where the random comes from. The 0.9 repeating is not the default value. That's the maximum value that math.random would return. If you want to see this, we can actually, why did I do that? I'll do this. I'll put a quick for loop in here for int I equals 0, I equals 99, I plus plus, system.out.println, and I'll call the math random function again. What this will do is this will give me 100 random numbers, and you'll see the range that it generates. None of the numbers will be less than 0. None of the numbers will be greater than 0.99 repeating. One convenient thing is if you use the up arrow, you could go up a command, down arrow, go down a command. I forgot a parenthesis there. This is a very descriptive error message, a legal end of expression. Some of learning error messages is a little bit of an art that you have to get used to. And of course, one problem might generate actually a couple errors. Oh, I see what I did. I put the I want to do equal, I want to do less than. All right, now if we run it, there's the random numbers it gave us. And you'll notice all of them are will be between 0, nothing's lower than 0, and nothing will be greater than 0.9999999. So nothing will have a 1 in it. Yes, between 0 and 1. Yeah, that should have been equal. Okay. So do you have questions about this one? If not, let's go into our next one. In our next one, we're going to have 2 classes. This is a little application that I use for a few class lectures that involves pricing a pizza. Here's the folder. It has in it, for each class, it has a source file and it has the object file that got compiled. Let me go into and again, I know I don't want to type in the long name, so I'll just CIPIZZ because I know it starts with pizza. And if I remember right, there's another paragraph, not paragraph, but folder here. So there are my files. All right. Now, in any given Java application, in a real life Java application, real life Java applications look something like this. We're going to have a GUI. That uses a bunch of classes. All right. Now, each of these classes could potentially be written by a different person, right? If this is a large project, you might have multiple people working on it, multiple people working on the classes. Absolutely order a pizza. I have one for me. The class, each class could be developed by a different developer. Now, then they're put together and they're tested as a unit. So there's testing on two levels. There's what is called unit testing. Unit testing is where this guy is going to test their class, and this person's going to test their class, and this person's going to test their class. All right, to make sure everything works with it. And there may even be like several classes that this person's responsible for. But at any rate, each person is going to test the pieces of code that they're responsible for. Then they're going to put it together and make sure the thing works together as a unit and works together with the GUI. All right. Well, we already said we're not going to develop GUIs. So how are we going to test our code? We're going to test it by doing what are called unit tests. We're going to have two different kinds of classes. We're going to have our unit test class. That's the boss. It's just responsible for using the other class and making sure the other class works. And then we're going to have the classes that do the work. And there might be one, later on there might be several. Start out, there's going to be just one class. And so if you look at the code that we have, that unit test is sort of a substitute for like a GUI, right? It's going to allow us to do things. Now, in this example, unit test is a unit test. Pizza is the pizza class. All right. So this is a little bit chicken and an egg situation for me to figure out which order is it the best to talk about. But I will talk about the pizza class first, and then we'll talk about the unit test. So the pizza class, let's take a look at it. Public class pizza. Okay, we've seen that before, right? Every class is going to start with public class, and all our code is going to be in classes. The name of the class is capitalized, and the name of the class matches the name of the physical file on disk. So in this case, the file name is pizza.java, pizza with a capital P. The class name is also pizza with a capital P. Now I have code here that is not part of any function. All right. These are code that are declaring attributes for the class. A class is a software representation of something. In this case, it's a software representation of a pizza. All right. And pizzas have certain characteristics. You can do certain things with a pizza. Or you want to know certain things about a pizza. In this case, to keep it real simple, we said the pizza has three attributes. It has a size, it has a crust, in other words, is it thick or thin crust, and then it has a Boolean of whether it's pepperoni or not. So true or false, yes.
It's like variables.
Those are variables, exactly. But there are variables that are available throughout the entire class. Okay. So sometimes these are called instance variables because each instance of the class has one of these.
Like the whole just throughout the
Right, right. Now these are listed as private, which is a little switch that we had in the other example. In the other example, we had everything public. Our attributes are going to be private until later on in the semester. Then we'll do something else. Protected. Is that standard practice? No, that's absolutely required. In fact, like if I'm grading on a Mac, I think Windows is a little forgiving about the case. But if I'm grading on the Mac and they are of different cases, I believe it won't do it right. It will say that it's a different name. So yes, make the class name the same as the physical file name. We don't want anyone, we want everything that's going to happen to these attributes to be controlled from inside the function. The only way that you can get to those attributes is by calling a function on this class. That gives us more control. Later on, for example, right now, we're not doing any validation, all right? Which, again, is a big inadequacy of this example, but pretend everything's okay with that, right? If I made this attribute public, then any other piece of code could set the value to anything. If I have it private, then they have to use the set size method, and I can put validation code in here to make sure it's one of the approved values. So you have to access the attributes through the set method. And a set method you define takes an argument that matches the type of the attribute and sets the attribute to that value. This also, by practice, and later on if you get into creating Java beans, is very useful. Take the set method, be the word set, followed by the name of the attribute, with the only difference being is that the first letter of the attribute is capitalized. You pay attention to what is capitalized and not is capitalized. These attributes are not capitalized. Neither are the methods. They use what's called camel case, which means that the first is lowercase, each subsequent word is uppercase. Now, string, notice that's capital, and Boolean is lowercase. I just want you to notice that for now. The answer to that, why that is because strings are actually objects. And integers or Booleans are what are called primitives. So it doesn't matter if you don't understand what that means today, but just understand it's not like they randomly decided to make string capital S. All right. It's done for a reason. All our object names are going to be capitalized, where all the primitives are lowercase. So for each attribute, we have a set method that takes an argument and sets the value of that variable. Again, right now, nothing fancy, but later on, we could put validation in there. Sets for cross, set for have pepperoni. Type matches the type. We simply set the value of that attribute to the value of the argument. We also have a get. Returns whatever type the attribute is, returns the value for the attribute. We're typically going to have gets and sets for each of our attributes. And they'll all sort of fit this model. We can have other functions too. In this case, what's one thing you can do with a pizza? You can bake it, right? So I have a little function here that calculates how long it takes the pizza to bake. And I made it real simple. If it's a thin crust pizza, it takes 10 minutes. If it is not a thin crust pizza, it takes 16 minutes to bake. Okay? So there's an if statement here. I set a value for the bake time. If the crust equals 10, I set it to 10. Otherwise, it's 16. And then I return the value of the bake time. Now, thing to notice here. I'm not saying if crust equals thin. All right? Again, this is another one of those things with, because strings are objects, if you ask if one object equals another object, it's not doing what you think it's doing, all right? Or what you might think it's doing. So instead, use the equals method for strings to compare them. So this is a pizza. It's an abstraction, if you will, of a pizza to the parts that matter for the problem we're trying to solve, all right? Obviously, there's a lot of other aspects of the pizza, right? How many slices you cut it into, all that. What we're saying is that's not important for what we're doing right now. So we don't have an attribute for that. How many calories, we're not interested in that. Now, we could be, in which case we'd add an attribute for it. But right now, we've abstracted it to only be interested in three things: the size, the crust, and whether it has pepperoni. And then we have a calculation to calculate the bake time. Now let's look at our unit test code. I'll leave that. I'm going to comment this out for now. How do you comment again? /* and a */. So I'm not interested in that right this minute. We'll come back to it probably before we're done. So pizza is a class. A class means it is a model, it is a template for all the pizzas in the world that exist. We have to make our specific pizza though, right? It's like if I was talking about a student versus I was talking about Trevor, right? One is an instance of that class. Student is a class. Trevor is an instance of that class. So in this case, in the application, the software, the piece of code that would represent Trevor would be an object. So classes are like a generic category of all the things that we're interested in of a particular category of things. An object is one member of that class. So we have to make a pizza in order to test it. Because we can't just test a pizza. We can't just test the sort of generic template for a pizza. We have to know the specific things, right? How big is a pizza? Is it small, medium, or large? Is it thick crust or thin crust? Does it have pepperoni or not? All those things are factors. So we have to make a specific pizza in order to test it. That's what this does. It makes a pizza object and puts the pointer to it in a variable called P1. So when I say P1 set size L, I'm going in, I'm calling that set method, and I'm putting a value L in the size attribute for that particular pizza. Now I have other pizzas, there could be other pizzas, as we'll see later on, right? And they have their values too. They will have their values for those things. Each instance will potentially can have its own value. So I set the 3 attributes. And then I'm going to output first pizza size is, and this is just echoing back what I set it to. So the size should be L, P1 should be thick crust or thin crust. This is going to be false. And calculate bake time, it will go through the calculate bake time for that specific pizza and give us an answer. So let's compile and run this. Compile without any errors. Now I'm going to run unit test. Why unit test? Something I forgot to point out. It's the one that has the main method. This code here to create a pizza and do all that is part of the main method. So that's why we're running it. So the first pizza size is L, thin, pepperoni, the bake time is 10. Is that correct? Well, we should verify it, right? Let's see, we set the size to L, and that function says it's L. So that worked, right? Set the crust to thin, and it outputted thin. So those set and get functions probably worked. Finally, we set pepperoni to false, and it says it doesn't have pepperoni. So those functions produced what we expected them to. Whatever value we set it to, it gives us that. Now, you really probably should test more than one, right? What if my function always returned thin for the type of crust? There was a bug in it or something, right? So you test it thick, you test it thin, you test it stuffed, whatever other values that the crust could have. And the bake time, does that work? Well, for a thin crust, the bake time should be 10 minutes, and it says the bake time is 10 minutes, so it worked. Now, does that mean our code works? No. That is one test case. We would want to run multiple test cases to ensure that it works. And that's what these other guys are. I'll uncomment these out now. I'm creating other pizzas. And how do I keep them separate? How do I know which pizza I'm referring to? By the variable I've given it. So if I say P1 set size or P2 set size, that's going to set the size of this pizza here that got created, not this pizza up here, so on. So at the very least, I want to test to make sure thin and thick crusts give me different values, right? Because that's two things that, or that's the thing that determines whether it is 60 minutes of bake time or 10 minutes of bake time. So I'm going to go, uncommented it, sure I saved it. Save all. Recompile it. Every time you change your code, you have to recompile it. Wait, a minute, I have two monitors. Nice. Spot there. Oh. All right, anyhow, I compiled it, no errors. Oh, I haven't hit return. All right, no errors. I'm gonna run it. All right, the bake time of the second pizza says it's 16. Is that correct? Well, our second one had thick crust, and thick crust, yes, it should be 16. The third one has thin crust, and yes, its bake time is 10. So we validated that the bake time seems to be working correctly. Again, we would likely do more tests in this to verify all combinations that we get the correct results. Are there any questions for what we have gone over today? Either from in here or people that are remote. Okay, review this. Go ahead.
So what was the pepperoni bouillon and the rest was string?
Well, this is like a cliffhanger, right? Like in a soap opera, you know. We'll find that out next week. All right. Right now, we're not doing anything.
Used to call it like.
Right now, well, later on next week, we're going to add another function to calculate the price of pizza, and then the size and whether it has pepperoni or not will come into play. Great question. Right now, we just wanted to set it up with, set up the attributes initially. Great question. All right, take the time, review this, make some changes to it. See if you can edit this function to give a different value if it's a stuffed crust pizza. Right? See if you can write a simple function to calculate bake time, so on. Do some additional tests, set some values. Yes, Trevor? You have a question, Trevor?
Yeah, can you hear me?
Yes.
I just had a question about the dot equals. Is that just used if you wanted to set something as a string, like without numbers, or does it use for other stuff?
It's not used for primitives. It's used for when you have classes.
Okay, I got you.
All right.
Makes sense.
When we study classes and primitives in more detail, we'll talk about actually the difference between those two things, because equal actually means something slightly different for a primitive versus a class. And if you just use the equal sign, you might not always get the results that you want. So yes, for strings or any other things that are classes, it's best to use the equals function. Other questions? All right, that's all I had for this week. Remember, the lab is optional. I am in the class WebEx room if you have questions and you want to ask them that way, and I will be up in person in BU 210, and you're welcome to come. If I see you in lab, either in person or virtually, I'll see you there. If not, have a good one. We'll talk to you next week. I thought I forgot to press record.